in watching this video is to expand your knowledge of adding integers into adding the rest of rational numbers. So quick reminder, rational numbers are any numbers that can be written as fractions. Remember, all integers are rational numbers because we can write them as a fraction with a denominator of 1. And you should already know how to add the integers that are rational numbers. Rational numbers also include decimals that end, like 2 and 751,000, because decimals that end can all be written as fractions. Rational numbers also include decimals that repeat. Alright, because they can be written as fractions. And finally, rational numbers include fractions, because they're already written as fractions. Okay, to add rational numbers, all you do is take the rules that we apply to integers for adding negatives, adding positives, and you apply them to what we do with fractions and decimals. Okay, so first, -8/3 plus 5/6. The book estimates their answer first, which I think is a absolutely fabulous idea, okay? So then you can check if your answer makes sense. So first they said, -8/3. -8/3 is a cheesecake, If I would change that to an integer, it would be about 3 negative cheesecakes, all right? And 5/6, if you cut up a cheesecake into 6 pieces and give me 5 of them, all right, that's pretty darn close to 1 whole cheesecake. Then, -3 cheesecakes plus 1 positive. The 1 positive cancels with one of the negatives, and we're left with -2. So our answer should be pretty darn close to -2. Okay, so now for finding the exact answer by adding those fractions, just combine our integer rules, our adding integer rules with our fraction rules. So we know that when we add or subtract fractions, they have to have the same denominator. Okay, so 3/6. -8/3 plus 5/6. We are going to turn those into two fractions that have the same denominator. If you can see their lowest common denominator, which would be 6, great, use that. You'll have less simplifying to do later. If you can't see that, remember you can always just multiply these two together to find a common denominator. Okay? I'm going to use the lowest common denominator in this case. Alright, I'm going to say that 3 and 6 are both factors of the number 6. So then I asked myself, okay, how did I get from 3 to its new denominator of 6? I multiplied by 2. To make an equivalent fraction, we have to do the same to the top. So -8 times 2 is -16. -8/3 is the same amount of cheesecake as -16/6, just written in a different way. Then we're going to change our second fraction. So my old denominator was 6, my new denominator was 6. All right, so actually I didn't have to change anything at all. I just took 6 times 1 to get 6. Then I just take 5 times 1, which is still 5/6. All right, now I can add my fractions together. Remember, adding fractions is just adding the numerators, -16 and 5, and keeping the same denominator. -16 plus 5, you owe someone $16, but you pay them back 5. Now you only owe $11, right? And they're 6. So -11/6 would be our answer. You could also change that to a mixed number and say -1 and 5/6. All right. On Edmodo, I would like you to submit the answer to this question. If you were adding these two fractions, would you do this the same way I did? So that could be your answer. I would do it like you did. Or do you have a different strategy to get the correct answer? Okay? Make sure whatever strategy it is, it works, and then tell me what it is. So either tell me, yep, I would do what you did, or nope, I think I would do it a different way, but it also works to get the correct answer. Tell me what that different way is. All right. Now, adding decimals. I think not nearly as bad as fractions, right? But that's me, I'm just not a fraction person. So here I would just say, oh, money. This already looks like money, it's beautiful. First person owes $4.05. Second person has $7.62. When we combine their money, let's start with this. Our final answer, do we have more negatives or positives? Okay, you owe $4.05. somebody else gives you $7.62. You're going to be able to pay off that debt and have money left over. Okay? So our answer is going to be positive. We have more positives than we have negatives. 7 is more than 4. Let's also estimate this before we start. Negative $4.05 is awfully close to just negative $4. And $7.62 is a little bit closer to $8. So negative 4 plus 8 would be positive 4. Our answer should be really close to positive 4. Okay, so we said our answer will be positive because we have more positives. Let's find out how many more positives we have. So we have $7.62 minus our negatives, 4.05. Okay, so we'll subtract and find out how many of these positives are left over after 4.05 of them cancel with these 4.05 negatives. Okay, so back down here, just follow my strategy that I've known since maybe 4th grade on how to subtract decimals. All right, 2 is bigger or smaller. I cannot subtract 5, so I'm going to borrow over here. Okay, make this 12. 12 minus 5 is 7. 5 minus 0 is 5. 7 minus 4 is 3. Okay, so I go over here. Remember, whatever I've left over are positives, and it's positive $3.57, or positive 3 57 hundredths. All right. Another set of fractions. Okay, I want you to submit the answer to this problem on Edmodo. Remember, you need common denominators. Okay, 8 and 4 are not common denominators, so find a common denominator. Add the numerators after you've done that. Keep your same denominator, and then write your answer in simplest form. Okay, evaluating expressions. My favorite, the part where it makes us look really smart. Okay, so we have 2x plus 2y. Oh, just plus y. All right, and it tells us that x is the same as 1/4. And y is the same as negative 3/2. Okay, so we're just going to plug those values for x and y into our expression. Remember to keep them in parentheses. So, too far there. 2, remember this means times. 2 times x. X is 1/4. All right, plus y. Y is negative 3/2. Okay, remember germ does, my order of operations. Is there anything in a group? Yes, but there's no operations. I can't do anything in either of the groups. No exponents, no rest. But there is multiplying or dividing. It's right here. 2 times 1/4. Remember that's the same as 2 over 1 times 1/4. And we can write that as, well, keep this here too so we don't forget about it. Okay, so multiplying fractions, my favorite, very easy. 2 times 1 is 2, 4 times 1 is 4. So now we have 2/4 plus negative 3/2. So we just finished up evaluating this expression. We're adding, we must have common denominators. We could multiply 4 and 2 and use a common denominator of 8. Or you could say, hey, I know that both of these numbers go into 4. 4 and 2 are both factors of 4. So 2 and 4's least common multiple is 4. Then I would say, all right, how did I get from this 2 to this 4? I multiplied by 2. So I need to do that to the numerator. Negative 3 times 2 is negative 6. I add, remember, add my numerators, 2 plus negative 6 over 4. All right, 2 positives and 6 negatives gives me 4 negatives over 4 positives, which equals negative 1. Okay, lastly, the table shows the annual profits. Remember, profit is money that a company makes after they pay all their expenses, okay? Of a financial company from 2008 to 2012. Positive numbers are gains and negative are losses. Which statement describes the profit over the 5-year period? So, let's look in 2008. This means at the end of 2008, this company had a bad year, all right? They lost $1.7 billion, okay? At the end of 2009, another bad year. They lost $4.75 billion, almost $5 billion. 2010, much better, they gained, all right? 2011, they gained money, not quite $1 billion, but that's still quite a lot. And 2012, they gained, all right? Well, I noticed something right here. 1 year they lost $1.7 billion, and 1 year they gained. So those 2 years, they balanced each other out. No profit there, no gains, no losses. So we could just take those off, all right? Now, which statement describes the profit over the 5-year period? Okay, find the sum of the profits. So already we know negative 1.7 plus positive 1.7 is 0.